Hello and welcome to the TTI Distribution Download, the podcast where we talk about all things happening in the world of electronic components with the specialists of TTI. And now, your host for the TTI Distribution Download, Paula Renfrow.
Thanks, Jim. Hey, everybody, and thanks for plugging into the TTI Distribution Download. In our final episode of the TE Connectivity series on battery energy storage systems, TTI Director of Supplier Marketing Scott Stemley and I are joined by subject matter expert and field application engineer at TE Connectivity, Brian Lineberry. Welcome, Brian.
Good to be here. Thanks for having me on.
And thanks to you too, Scott, for bringing your perspective and distribution perspective to the series. I've appreciated it a lot. It's been fun. Brian, tell us a little bit about your career journey and the work you do at TE.
I've been with TE for 35 years. I've been working in relays and DC contactors for about 17 years. I started off many years ago in the test laboratory, and then I had a stint in quality, but I've been a field application engineer now for about 14 years, I guess, something like that. So anyway, that's me. I'm based in North Carolina. And
are you from North Carolina?
I am.
Oh, I got just a little bit of twang there. I like it.
All right.
So, Brian, how about we start today with an overview of the effect of smart charging products and bidirectional charging technologies and capabilities? Like, how about examples of the markets that are leveraging this technology today?
Yeah, I got a couple of examples that comes to mind where bidirectional charging would come into play, I think. In the transportation world, you might have heard of V2G, vehicle to grid, where the vehicle is plugged into the home, for example, and then in these kinds of cases, you might hear the phrase dynamic load management. In this model, the idea is for an electrical company, a municipality, to have all of these electric vehicles available to help load manage or balance loads as maybe the vehicle is not in use. Consider, say, a school system that's got, say, a fleet of 100 school buses. If they were electric school buses, they would be in use part of the day, each day, but a lot of the time they would not be in use. And each bus represents a source of battery power sitting there, available for load sharing during times of the day, certain times of the day. So the bus could be charged when the electricity is inexpensive. It can be made available back to the grid. So that's back and forth. It's not just charging, but discharging the battery onto the grid. And that's kind of a bidirectional kind of an example. Mm-hmm. Another example, I guess more to our focus today, is in battery energy storage systems. These are systems that can be simple at a residential level, or they can be complex and large at commercial, industrial level, even grid scale battery energy storage systems. And the idea is the same as with the transportation example, is the battery is a storehouse of energy. Not only does it need to charge, but it needs to discharge, and not only to the load that it might be supplying, but maybe even back to the grid in that case as well. So a battery energy storage system could be at a grid level involving solar panels. It could be accessing car batteries, vehicle batteries, and so forth. But just being able to transfer current in two directions, in and out, charge and discharge at any given time, is kind of the bidirectional aspect of it. So there's a lot more examples as we get more and more into the electrification of everything.
So talk about the key components, in that technology, in that bidirectional situation. What are the key components from a relay and a contactor?
At a high level, a battery energy storage system is going to have to have a battery. Could be small, could be large, but obviously we understand the concept of a battery, some kind of a way to store the energy. But there's also going to be a battery management system in there as well. And the BMS is kind of like a traffic cop that intelligently directs the current flow depending on the situation that it's in at the moment. It's also responsible for safeguarding the batteries, and because batteries have limits on how fast they can be charged, for example, and under what conditions, environmental conditions, they can charge at that speed. All the equipment is subject to serious safety concerns. Sometimes we hear about that in the news as well. The BMS monitors all of this and is directing current flow. Then there's the power conversion system, and this is where it gets closer to our world here at TE. The power conversion system is that piece of the energy storage system that is constantly converting electricity into AC to DC or DC to AC. It could happen multiple times, during a day, during an hour, during a minute, maybe even depending on what's going on around it and what it's programmed to be as a load profile, a control profile. Well, it has to do this in both directions, like in the case of the school buses or the energy storage system, behind our house, battery backup in case of power outages. The power conversion system has to be able to come into play at a moment's notice to convert that energy back and forth, so that's the back and forth, the bi-directional, as opposed to the older conventional single directional, just charging a battery. Now we need intelligent ways to discharge the battery at a specific time under specific conditions. So then that takes us kind of to the components of the power conversion system, and it's especially in the power conversion system, but also in other places in the energy storage system. But in the PCS, the contactors, DC contactors, are most often used as a disconnect means, an emergency disconnect means. They don't typically cycle a lot. They're typically going to be closed, energized. But if something gets too hot, something gets above the limits, an unsafe situation arises, the BMS needs to communicate with the power conversion system and open this contactor quickly. So that's the primary role of a DC contactor in battery energy storage. And because it's in that system, the contactor itself, the component itself, needs to have a bidirectional capability as well. The contactor will have oftentimes an auxiliary contact. Not the main contact, but an auxiliary contact, which provides feedback up to the higher level, the smarts of the system in the BMS, for example. So it's monitoring the state of the contactor. It's monitoring the temperature of the contactor. All of this comes into play for safe operation of the entire system. So that's kind of starting at a high level, but kind of coming down to the contactor. Those are the primary components, and we at TE, especially with the interconnects that we sell, and the DC contactors and relays as well for the power conversion system.
How do relays and contactors improve upon the older technologies when it comes to battery storage systems?
Yeah, I guess the main thing that makes these smart systems possible is the bidirectional design of the contactor. And there's a lot of components, but the contactor is our focus here. Traditionally, DC contactors would use a magnet inside the contactor. The magnet is there near where the arc is created. As a contactor opens, there's an electrical arc that is created inside. As the contactor disconnects, as we mentioned earlier, that disconnection of the circuit, that electrical arc is that impacts the contactor life. So we want to reduce the arc. How do we reduce the arc? Well, one of the traditional ways to do that is to place a magnet in such an orientation very close to that, so that the magnetic field from that tiny magnet actually stretches or curves the arc, making it longer. And because it has to take a longer path, the arc will break quicker. And that's ingenious, but that's been around for a long time. Bidirectional contactors take that same design idea to the next step, and we still would use a magnet, but it would be maybe multiple magnets with the polarity changed and reversed, so that no matter if the current is running, charge or discharge, whichever direction, it has the same magnetic poles that provide that arc breaking design. So it's the availability of bidirectional contactors that really contribute a lot to this bidirectional charging of these smart systems.
So it sounds like it's really enabling a dynamic and efficient charging process. Can you tell us more about how they are enhancing the flexibility and functionality of energy storage systems?
Yeah, the contactors, they are standardized. They have to meet industry and agency standards, UL, IEC, for example, standards, and the industry seems to be, I guess, centering around a couple of different breakpoints in battery energy storage systems, 1,000 volt systems, for example. So a company like ours, we would have a 1,000 volt portfolio. That's our ECK line of portfolios, and our ECK line of contactors, and then there's 1,500 volts as well. So having multiple designs at some of those natural breaks in the industry standards, it provides a customer more options to choose from. So there's some flexibility there because of standardization across the industry, and then component manufacturers like us designing to those standards.
So Brian, if I'm an engineer that's just going to work, on a battery management system, right? And I'm in the market, I'm in the need, I should say, for a solution like this. Where would you start in the TE product line?
Yeah, I guess I would start. There's just a few basic questions to get the conversation started. One is, what is the system voltage? Is it a 1,000 volt system? Is it a 1,500 volt system? What's the max carry current that the system will require? And by carry current, that means, as I mentioned earlier, these systems would typically be designed the contactor would close before the current flows, and then the current flow would stop before the contactor's open. So the contactor does not switch the current; it only carries the current. So a little extra lingo there, but the carry current. What's the carry current that this particular design would need? Also, do you need an auxiliary switch? And it's not required in all cases, I think, but so a few questions like that, and we could begin to point the engineer to what TE has to offer. Those are typically the things that are going to be necessary to pick a good contactor to be a solution.
As a subject matter expert and having spent a lot of time here without naming names, customer names, is there a common miss? Is there a little something that is just overlooked most commonly in this application?
I think one thing, and I can't prove this yet, but I suspect one thing that's happening is the auxiliary contacts inside these contactors. It's just typically it can be as simple as crude as just a micro switch inside the vacuum chamber of the contactor, and it doesn't have the reliability in some cases, we think. And it's one reason that we've looked at improving we are improving actually with new part numbers, the reliability of auxiliary switch. The reason that's important is because the battery management system relies on the auxiliary switch. It can't be any doubt about the state of the contactor. Is it open or closed? It gets that typically from the auxiliary switch. There's other ways to design around an auxiliary switch, but if an auxiliary switch is necessary, that's an area that I think that can be overlooked, is the reliability of the auxiliary switch. Another thing that should be taken into account is the size of the conductor cable. that is used to wire up these contactors. The conductor cable is a key component to managing the heat that's generated at the contactor. So just because you have a conductor that's rated for 300 amps, it needs to be matched better to the contactor. You can get more current flow out of a contactor by using a larger conductor because it sinks the heat away from the contactor. So those are just a couple of things that come to mind.
A couple tips. Yeah. Thank you for that. So Scott, this product line, these product technologies, is this common? Is this available to sell inventory at TTI, or are these special items?
No, there's a line of standard product that TTI carries, both on the relay and contactor product. So yeah, those are available today within TTI's portfolio.
If I could add one more.
Sure. Yeah.
If I could add one more thing, I've focused so much on the contactor, but our portfolio of relays is pretty generous as well. A pre-charge contactor. This is I've been talking about the main contactor that switches the hundreds of amps, but these systems also require a pre-charge contactor. We have pre-charge contactor at TE that's smaller and it's designed to kind of work in parallel with the main contactor, and it's to help protect the main contactor in a pre-charge circuit. And pre-charge resistors or passives, large off-board power resistors, we have as well. So the relays. Electromechanical PCB, DIN rail mounted relays. These would be in the control circuits, signal relays that would be part of a battery energy storage system, not on the power switching, the heavy switching side where I've been focused with the contactor, but more on the lower level control side.
Perfect. Thank you.
Fascinating. I know I said earlier in this series, I really do enjoy every time we have subject experts on and we get to talk about energy storage, battery size, what's going on, in transportation. We're big in transportation here. We have our own transportation business unit, and how it's just really evolving the convenience, right, of our lives. And that's just one thing, but everything needs power.
You kind of take it for granted. You go to the garage and start your car up,
right,
or you plug it in when you come home from a day of work, and you don't really give it two thoughts. But the complexity of the system, the reliability that is behind all of that is critically important.
So thank you for sharing your insights and your time with us today, Brian.
Great. I really appreciate the chance to be on, and I'm happy to support.
Thank you. And as we're just saying, this is just going to keep evolving. So we're going to need to get back together again in a couple of months and talk about where we are today, where we're going. And thank you, Scott, for hanging in and riding shotgun. It was fun, and I hope you'll join us in the booth again.
I will.
Good.
For sure.
Good. Thank you to our listeners for plugging in. If you learned something about battery energy storage systems, be sure to keep an eye on TE Connectivity and their advancements in a certainly critical application of our times. For more insights on battery management and power technology in general, visit our Power Management Resource Center at tti.com/marketeye. Until next time, I'm Paula Renfrow. This is TTI Distribution Download.
That's it for this episode of the TTI Distribution Download. For more information on any of the topics you heard about today, reach out to your nearby TTI branch at 1-800-CALL-TTI or visit us online at tti.com.